Good day, everyone. Today we are going to start learning the addition and subtraction of vectors. So sometimes you can have two vectors that we wish to add together. So how do we do that? So addition of vectors can be done in two different ways. The first way is the parallelogram method. This method just is very simple. What this method is implying, or what this method states, is that if you have two vectors that you want to add together, then complete a parallelogram using these two vectors. Then draw a diagonal line from where these two vectors meet to draw a diagonal line across the parallelogram, starting from where the two vectors meet. So what's the meaning of all of this? Consider this example. Say I want to add vectors A and B. I want to add vectors A and B. So I intentionally left this vector C for us to see something. Say I want to add vectors A and B. What do? I said I should complete a parallelogram. So a parallelogram is a quadrilateral, right? So with two parallel sides, with two pairs of parallel sides. So what am I going to do? I should complete a parallelogram with this. So I want to add positive A and B. So I could just copy this, then complete a parallelogram. That's, I'm trying to complete a parallelogram like this. Then if I duplicate this also, let's see. So let's also duplicate this and bring it here. So now that's the first step. We have completed the parallelogram. So now we have a parallelogram here. This is my parallelogram. See, let's draw it with the black shape. This is my parallelogram, because this rectangle is a parallelogram. This is my parallelogram. So that's the first step. First step is what is making drawing a parallelogram from the shape. Then I said that the vector will now be equals to what this resultant of the two vectors will be what the vector that is taken from where the two of them intersect. So let's go back. So now I said to get the new vector, the resultant, that's the addition of the two vectors, we will take it from where the two vectors, the initial two vectors, intersected. So let's use yes. Let's see. So I'll draw it from this point, then I'll draw a diagonal line. But notice that this diagonal line is just what vector C. This diagonal line is just what vector C. So this in essence is proving the point that we made in a previous video, that vector C is just equals to what vectors A plus vectors B. If you can recall that we established this in a previous video, that vectors C is equals to vectors A and plus vectors B. So I didn't intentionally do any proof, because I knew we are going to learn how to add vectors later in the future. So that will be that for today. Thank you all, and see you guys in the next one.